This video will cover problem 5 from section 4.2. So sometimes problems, they could increase exponentially or decrease exponentially, but they're not necessarily going to decrease to zero or increase to another number. So sometimes we have to use a different type of functions, and such as the one that we have here. And what we're doing here, actually, with this number that is being added to the negative e, is going to change the horizontal asymptote of our function. And for example 5 here, we have a business example. It says sales of a new product often grow rapidly at first and then begin to level off with time. Suppose the annual sales of an inexpensive can opener are given by, and we have the function here, which is being called s of x. And for x equals 0, that corresponds to the time the can opener went on the market, so when it started being sold. So what we need to figure out first is what were the sales in each of the first 3 years. So then since x equals 0 corresponds to the beginning of the can opener, so then after 3 years we're going to make x equal to 3, and therefore we're going to find s of 3. And so the way we're going to type it in the calculator will be 10,000 parentheses, then e minus, the big minus, then e, and then exponent. And then here we're going to need the little sign for negative 0.5 times 3. We close the parentheses for the exponent of e, and then we have to close it again to enclose this one here. So then after that, you could press enter, and then you will get approximately 7,769. So now for part B, the question is, what were the sales at the end of the 10th year? So now we're going to find, now we're going to make x equal 10, and we're going to find s of 10. So that will be 10,000 parentheses 1 minus e to the power negative 0.5 times 10. This one to close the exponent, and this one to close the parentheses before the number 1. And so with that, we're going to get 9,933. So now for the next one, it says graph the function s, and we do have the graph here. I know I already wrote on it, so but you could still see it. So it is this line that is going here, growing there, and what it suggests is that the graph can be obtained by plotting the points, or you could put it on the calculator, and the graph indicates that sales will level off after the 12th year to around 10,000 can openers per year. So if we look at this number here for the horizontal asymptote, that will be, actually it would be above, that would be that line that is leveling the function at 10,000. So this will be the y value 10,000. So those type of functions, so let's write this, the graph will level at 10,000 can openers. So even if we were to increase the value of x, we're not going to go past 10,000. And so this type of functions, we call them logistic functions. Another way to write this function here that we were given, well, let's not do that one. Instead, I will write you the general form for all logistic functions. So that will say f of x is equal to c, that being a number, divided by 1 plus a, that's also a number, e, that's also a number, k, that's also a number, and then x will be the independent variable. So now for example 6, and that is how the function that you have on example 6 looks like, if you see. And the number that we have on the top is going to be the one that will level off to. So to answer problem A, well, first of all, it says here that instead of using x, we're using t as our independent variable. And for problem A, it says, what was the price of U.S. scrap steel in 2011? Now, let's point out that for t equals 11, that corresponds to the year 2011. So then we have to answer this question when t equals 11, because that's the year that we're being asked to find. So we're going to find h of 11, and so that would be 496.7 divided by 1 plus 0.00048, and then times e to the power 0.64 times 11, because that's the value of t that we're using. And so by entering that on the calculator, we're going to get 470.90. By the way, this problem is about the price of U.S. Scrap steel in U.S. dollars. So then in 2011, the price was $470.90. Now, what was the price for the year 2016? So we're finding h of 16. And so that would be 496.7 over 1 plus 0.0000. For this problems, it's very important that you do enter the numbers exactly like they are. And in this case, I'm going to put the exponent 0.64 times 16. Okay, and so we enter that on the calculator, and we're going to get $211.90. Now, you could see that the price dropped by quite a lot in 2016, from 2011 to 2016, less than half actually, in 5 years. So for part C, we're being asked to draw the graph. So you can enter the graph. You might want to use a fraction tool, or if not, make sure you do enclose the denominator in parentheses when you enter it, so that you get an accurate representation. You also want to change your window so that your minimum x value is a 10. I'm sorry, it's 10, yes, and the maximum is a 17. Then you want your minimum y value to be a 0 and your maximum y value to be a 500. That way you will get a good picture from that. Also, because you're being told here. So that's why we use x equals 10 for the year 2010 and x equals 17 for the year 2017. And so this is the end of the video. Thank you for watching.